The evolution of Starship, from rough prototypes to sophisticated spacecraft. The initial Starship prototypes unveiled by SpaceX appeared remarkably rudimentary, raising questions about their ability to withstand the harsh conditions of space travel. However, the current iterations of Starship boast a significantly more refined design, featuring smoother metalwork and less conspicuous welds. This transformation begs the question: what drove this rapid evolution, and will Starship ultimately achieve the sleek, polished appearance depicted in its conceptual renderings? To address this inquiry, it's essential to examine the underlying reasons behind Starship's distinctive design, particularly its large, shiny appearance, which deviates from the typical white, slender profile of most rockets. Interestingly, Starship was not always intended to resemble a 1940s science fiction-inspired spacecraft. Initially, the plan was to construct Starship from carbon fiber, with production already underway in California. This approach seemed logical, given carbon fiber's exceptional strength and the fact that SpaceX had a significant workforce based in the state. However, the sudden emergence of a stainless steel Starship in a small Texas village caught many by surprise. Over time, the rationale behind this decision became apparent. While carbon fiber is incredibly strong, it begins to degrade at temperatures around 200 degrees Celsius. To withstand the 1,600-degree temperatures encountered during multiple re-entries, a thick heat shield would be necessary. In contrast, stainless steel can handle much higher temperatures, requiring only a thin heat shield. Furthermore, stainless steel is significantly cheaper than carbon fiber, with a cost of just $3 per kilogram compared to an astonishing $150. This is not the first instance of a stainless steel rocket, as NASA developed an Atlas rocket using incredibly thin stainless steel in the 1960s. Although this design was innovative, it proved problematic, as the rocket's thin structure was prone to collapse under its own weight unless constantly pressurized. Even if SpaceX had opted for carbon fiber, it's uncertain whether Starship could have been successfully manufactured. Producing carbon composites requires layering fibers in a precise manner to achieve strength in every direction. The composites must then be cured in a massive pressure oven. For Starship's 9-meter-wide sections, an oven larger than any existing facility would be necessary. The shift to stainless steel has enabled SpaceX to overcome these challenges and create a more robust, cost-effective spacecraft. As the company continues to refine its design and manufacturing processes, it's possible that future iterations of Starship will feature an even more streamlined appearance. However, the current design's functionality and durability are likely to take precedence over aesthetic considerations. In conclusion, the evolution of Starship from rough prototypes to sophisticated spacecraft is a testament to SpaceX's adaptability and innovative spirit. By embracing stainless steel and refining its manufacturing processes, the company has created a more viable, cost-effective spacecraft that is poised to play a significant role in the future of space exploration. The advantages of stainless steel: overcoming welding challenges in Starship development. The use of stainless steel in the construction of Starship proved to be a game-changer for SpaceX. Its ability to be quickly assembled using basic and affordable methods made it an ideal choice for the company's ambitious project. However, the initial Starship prototypes faced significant challenges, particularly with regards to welding. The early prototypes were constructed from several sheets of 301 stainless steel, each approximately 4.5 millimeters thick. The welding process used at the time, flux core welding, involved passing a voltage through a metallic wire to create an arc between the wire and the metal, causing it to melt. The tip of the wire would also melt and fall into the molten stainless steel, filling any cracks or air bubbles. This method was surrounded by a solid material that burned and released a protective gas, shielding the weld from atmospheric oxygen and preventing corrosion. Despite the theoretical advantages of flux core welding, the reality was far from ideal. The Starship crew, contracted from a water tower company, lacked experience in building rockets, and the welding standards were consequently subpar. The lack of a proper factory environment, with most welding taking place outside in a large tent, further exacerbated the issue. The welds on the first Mark I prototype were heavily corroded, with cracks and rough edges on the surface. To address these issues, SpaceX employed a grinding process to smooth out the welds, making them flush with the surrounding surface. While this may have appeared to be a cosmetic fix, it was actually a crucial step in strengthening the welds. The sharp edges and tiny cracks on the surface acted as pressure points, which could lead to larger cracks when the Starship was pressurized. By grinding the surface, these defects were removed, reducing the likelihood of weld failure. In theory, each weld should be as strong as the surrounding metal. However, the initial Starship test proved that this was not the case. The Mark I prototype exploded when one of the horizontal welds failed, sending the bulkhead flying. This catastrophic failure led SpaceX to implement significant improvements in the next Starship prototype. The new design featured thinner, single sheets of stainless steel, requiring much less welding. This change, combined with the company's growing expertise in welding and material science, has enabled SpaceX to produce a more robust and reliable spacecraft. As the company continues to refine its design and manufacturing processes, it is likely that future iterations of Starship will feature even more advanced welding techniques, further enhancing the spacecraft's performance and safety. In conclusion, the use of stainless steel in Starship's construction has presented both opportunities and challenges. While the material strength and affordability have been significant advantages, the welding process has required significant refinement. Through a combination of innovative design, improved manufacturing techniques, and a commitment to quality, SpaceX has been able to overcome these challenges and produce a more capable and reliable spacecraft. Advancements in welding technology, enhancing Starship's structural integrity. As SpaceX continued to refine its Starship design, the company made significant upgrades to its welding process. One notable change was the transition from 301 to 304L stainless steel, which offered improved resistance to corrosion during welding. This switch was accompanied by the adoption of TIG welding, a technique that provides greater control over the welding arc, allowing for tighter welds and deeper penetration into the metal. The result was thinner welds with reduced warping of the surrounding metal. To further enhance its welding capabilities, SpaceX invested in robotic welding machines from companies like Liberty and Kuka, similar to those used in Tesla's factories. This automation enabled the company to produce cleaner and more precise welds, significantly improving the overall quality of the Starship structure. In addition to these advancements, SpaceX also began installing more stringers on the inside of Starship's hull to prevent the metal from buckling under its own weight. This added reinforcement ensured a stronger and more stable structure. It is likely that SpaceX has since transitioned to laser welding for many of Starship's sections. Laser welding offers a more concentrated heat source, allowing for deeper penetration into the metal and enabling the ring segments to be welded in a single pass. This technique has the potential to significantly improve the strength and efficiency of the welding process. However, to further enhance the strength of each weld, an additional process is necessary. During the production of Starship's stainless steel, the metal undergoes a process called cold rolling, which involves passing the metal through a series of rollers to compress and stretch the grains. This process makes the material stronger and harder. However, when the metal is welded, the heat causes the surrounding area to soften. To address this, SpaceX employs a giant planishing machine to hammer the welds down and compress them until they match the hardness of the surrounding metal. This process not only improves the strength of the welds, but also smooths out the finish, enhancing their appearance. While it is possible to achieve a completely smooth finish, similar to a mirror, it is unlikely that SpaceX will pursue this for Starship. The process of polishing the entire body to achieve such a finish would be extremely time-consuming and labor-intensive, as evident from the 8-month polishing process involved in creating the famous beam sculpture in Chicago. Despite the challenges, SpaceX's dedication to innovation and quality is evident in its rapid progress on the Starship project. The company's commitment to pushing the boundaries of technology and engineering is inspiring, and its achievements serve as a testament to the power of human ingenuity. If you have any additional information on this topic that can help us enhance our future videos, please feel free to leave your comments below. Thank you for watching. Don't forget to like and subscribe to our channel to support us and receive the latest updates from Universe X. We truly appreciate all your support and look forward to continuing to provide you with quality content.